Wouldn't it be great if code had a checklist? You check all boxes and your new app is ready to ship. Unfortunately, building software is more like this. In this video you learn how to add asserts to your code to make sure everything runs like clockwork. Let me start by showing you what an assert looks like in Python. The assert statement in this code checks if a radius is greater than 0. I execute the code. The radius is greater than 0, the text is printed and the program exits normally. I set the radius again, but this time to -40. I execute the code. And now an assertion error is raised by Python. Notice that the second text is not in the output, and that is the first thing you need to know about asserts. When an assert fails, an assertion error is raised and the program's execution is stopped. The assert statement can have a second argument, which is a description why the assertion error was raised. I execute the code, and now the error shows exactly what went wrong. Now you know what an assert looks like in Python, but the assert in this example is not very useful because the checked variable was assigned a fixed value just before the assert. So, when are asserts useful? To answer this question, I need to tell you about invariants. An invariant is an expression that is always expected to evaluate to true. When the invariant evaluates to false, the program is broken and cannot be repaired. This leads to an important conclusion. When asserts fail, the goal is not to inform the user of an error, but inform the developer to fix the bug. Let me give you an example. Look at this function. It takes a user and group and inserts the data into two tables. I call the function and pass a name and group. I execute the code, and here is the result. Two tables are updated. If you have worked with databases before, you know it is very important that database actions either succeed or fail. But this code can cause the database to be corrupt. I add user Dave to the database, but Dave's group has value none. I execute the code and look at the output. Dave is inserted in table user, but not in table group. Dave's data is corrupt. This situation should never happen. It is a bug in the system. There are many ways to solve it, and one of them is to use an assert. I add an assert to check if group is not none. Notice the position of the assert statement. It is the first thing in the function. That means that if group is none, the program will crash. I execute the code. Look at the output. User Vera was inserted in the database successfully, and Dave was not inserted at all because the system crashed before even attempting to access the database. The assert in this example is used as a precondition in the function. I'd like to repeat that the goal of asserts like these is to check for invariants to be true, and if they are false, you should be informed there is a bug in the system so you can fix it. Let me give you another example of an assert. Look at class Shift. It has class variables start hour and end hour. Notice that their default values are set to -1. I add two methods, clock in and clock out. Method getWorkTime calculates the worked hours. I create a Shift object, clock in and clock out, and print the worked hours. I execute the code, and here's the result. Everything works as expected. But now I forget to clock out. What happens when I execute the code? The system did not crash, but the result is wrong. Bugs like these are very hard to find, and an assert can help us here. I add an assert that checks if both times are greater than -1. I execute the code. Python tells exactly what went wrong and also where. I fix the problem by clocking out. I execute the code again. And everything works again. But there is another potential bug in this code. What happens when the end time is before the start time? I execute the code. The worked hours are not correct. Since this is a unique problem, I create a separate assert. The assert checks if the end time is greater than the start time. I execute the code. Python detected the incorrect object state. Objects have lifetimes, and during their existence, their state is expected to be updated. That is why it makes sense to perform sanity checks before interacting with them. You have seen how to use asserts for this. Until now, I used asserts during development, but asserts can also play a huge role in finding bugs in a system that is already in production. When my team was working on the Windows version of Wunderlist, the program had a bug that happened only once in a while. As you know, bugs that are rare are hard to trace. Sometimes users would click on a task, but the app crashed, saying it could not extract the task ID from the clicked item. To find the bug, we started placing asserts in the code in the hope to find the bug. The handling code checked the type of the clicked item and either showed task details or toggled the header. Since we never noticed the bug while we were developing the system, we had to place asserts in the hope to find the problem. One of the asserts checked to make sure that the clicked item was indeed a task or header, and although we never thought this could be the problem, it led us to the bug. It turned out that when users clicked on this white space, the system would also trigger the item click. The assert detected the problem. The bug could be fixed by explicitly checking on header item as well. After a while, we noticed the bug disappearing from the bug reports, and we could delete the assert again. And that answers another question you might have. Should asserts be in the code that is in production? As you have seen, it makes sense to leave asserts that check object state, but if an assert was only placed to find a bug, once that bug has been fixed, you might as well remove the assert from the code. So as always, it depends. Let me show you another reason to have permanent asserts in your code. Look at this code. A start and end date are retrieved from a project object. Line 4 contains a comment to inform the developer that the end date must be greater than the start date. That might be helpful to understand the calculation in line 5, but it won't ensure it, of course. You can turn the comment into an assert. This technique is known as active comments. The same information is conveyed to the reader of the code, and the system will ensure the rule. But whatever you use asserts for, remember they are for finding and fixing bugs, not to handle them. Why is this so important to know? Look at class employee. It has a method to set a name and a method to set a salary. Notice that the getInfo method asserts that both name and salary are set. But when the assertion fails, the program crashes. Wouldn't it be much better to prevent incorrect data at all? Of course it is. You can make sure the employee object can only be instantiated with the correct data. This can be done with a class initializer. In this example, I would not even expect an assert in the getInfo method. So, perhaps your next question is, Should I use asserts to check for the user input then, to make sure that valid names and salaries are passed to the employee object? The answer is no. Asserts are for finding bugs, and let me explain why I repeat this so often. Asserts are disabled in release mode. Once a program is deployed, your assert might not be active anymore. To learn about debug and release mode, I recommend to read the documentation, and I'll put a link to it in the description. For this tutorial, it is enough to know that asserts are for finding bugs during development. They are a powerful tool to make your code rock solid, and they are a good addition to another technique you can also use to check your code during development. And that is unit tests. And to see how that works in Python, click on the screen and we'll see each other in the next video.